to kind of summarize, but to really absorb the power of what we did in the last few videos, what I want to look at is if we had something like -4 to the 100th power. Remember what this means expanded out is -4 times -4 times -4 times -4 times -4, 100 times. Even just -4 times itself 4 times is already going to be in the hundreds. You're going to get an absolute gigantic. Even a calculator is going to be confused when you try to put that kind of number in. Scientific notation is the only way we're going to get a number that large. The last thing we want to do in our lives would ever be try and multiply -4 times itself 100 times. Well, remember what this means, though, is if I have -4 times itself 100 times, the fact that that's an even means I have all of those pairs. -4 times -4 would be positive. -4 times -4 would be positive. -4 times -4 would be positive. I would keep having all these pairs that would be positive, positive. I'd have 50 pairs. But what would happen is, because that's even, all of those pairs would give me a bunch of positive numbers, giving me a positive final product. Well, think of if I had -5 to the 100th power. Remember what this means is -5 times -5 times -5 times -5. -5 times itself 100 times. The reason I showed this example is that it doesn't matter what your base is. Whether it's -4 times itself 100 times or whether it's -5 times itself 100 times. I still have 100 of each of those negative bases. It's still going to be that same effect. -5 times -5 is positive. -5 times -5 is positive. -5 times -5 is positive. And yes, this is going to be a ridiculous, in fact, even far more gigantic than that number. But the fact is that I still have 100 of those 5s, all those pairs, again, 50 of those pairs, all giving me positive numbers, giving me a final positive product. Well, when we look at -4 to the 125th power, again, an absolute gigantic number. Even a calculator would get upset with you. -4 times -4 times -4. I would have a bunch of those pairs. -4 times -4 would be positive. -4 times -4 would be positive. But because that's odd, I would have that leftover negative at the end, giving me a negative answer. So even though I had an even base, it has nothing to do with what your base is. In fact, you may even want to ignore your base. When I have a negative base, it all has to do with, is it even or is it odd? That even means all my negatives are going to cancel out. I got a positive answer. That odd is going to mean I'm going to have a whole bunch of negatives cancel out, but that odd means I have that one leftover negative, making my answer negative. If I have -5 to the 125th power, 125 of those -5s means I have that one left over, making my answer negative. Again, it has nothing to do with that being odd or even. It all has to do with the exponent being odd or even. One of them I do want to show us is, what if we have -4 to the 100th power? When we look at this problem, a negative times a negative, we want to think that's going to be positive, but remember, order of operations, we got to do the exponent first. What's this negative in front? It's that same -1 coefficient. What this means is -4 times itself 100 times, as you would with a base. A base times itself the exponent number of times. -4 times -4 times -4 times -4. If I have 100 of those -4s, this is going to give me a positive product. Absolutely gigantic, but a positive product because of that even exponent. Well, if I have a negative coefficient, -1 times whatever that positive gigantic number is going to give me a negative number. When I have a negative in front, as we said last time, it gives me a negative answer. That's what a negative coefficient is going to turn your entire answer negative. Stay away from that habit of thinking negatives will always cancel. They cancel when I just have two individual negative number times negative number, not when I have a coefficient and a base.